Hi. Well, welcome back, everyone. We'll talk a little bit about storage on AWS. We'll do a quick introduction. We'll talk a little bit about block storage, share file systems, object store, and how you can integrate your on-premise storage to different AWS solutions. So why choose storage on AWS? There's several reasons why, as opposed to having to purchase storage solutions, you can have you can pay as you go. You can have only the storage that you need. There's no capacity planning. There's no need for budgeting for storage, right? There's no need to provision redundancy or making sure that you have additional devices. And it's easy to use. It's easy to administer, it's easy to manage. You can write automation around it. You can use CLIs and SDKs to integrate with your application or your current processes, and there's no commitment. You only pay for the storage that you need now. It also helps you reduce risk. Risk of storage devices going bad, or risk of storage devices running out of storage. So you avoid all that physical handling of the media, those storage devices that you don't have to worry about destroying those because your client's data is in those after you're done using them. It also gives you a lot of speed, agility, and the ability to scale. Right? It allows you to provision as much storage as you need when you need it. So you don't have to place an order. You don't have to wait for those storage devices to arrive so that you can install them on your data center. Right? And instead, you can work on your business and use those resources to build your business and not worry about your storage infrastructure. Talk a little bit about the basics of storage. In AWS, there's block, file, and object storage. For block storage is basically raw storage that you use for organizing your data as an array of unrelated blocks, right? Things like hosting a file system. As example, you can relate to something like Microsoft NTFS, or a Unix ZFS file system. File storage is basically unrelated blocks of storage that are managed by a file system, just like a native file system on your disk. And then there's block storage. Block storage is basically pieces of information that you store not in a file system type of array, but basically files or images or pieces of data that you can store, and you can attach attributes to it. You can attach IDs. You can attach metadata to those objects. There's also the ability to access those or manipulate those using APIs and the command line interface. So understanding a little bit about durability. When we talk about something that's designed to have 4 nines of durability, that means that you usually have 2 copies of that item in one site. When you have 5 nines of durability, then you have 2 copies on 2 sides. So it's harder for you to kind of lose that data. And in the case of something like S3 that's designed for 11 nines of durability, then you have multiple copies across 3 AZs, right? And then we'll talk a little bit more about the different storage levels or the different storage types that S3 allows, and how you can move your unused files or files that you don't frequently access to longer term storage, such as Glacier, which is an archive storage. We'll talk a little bit about that later. So availability versus durability. And it's basically, availability is basically the probability of your file not being available in the course of a year. Whereas durability is the probability of a file being lost, or your object being lost. And as you can see here, the higher the number of nines, the less likely it is for you to lose that file, or that file not being available for you. AWS has different types of storage options, and these are just a few, and we'll talk a little bit more about these a little later. But we talked about elastic block storage, and that's basically network storage. Again, we'll talk a little bit more in depth about block storage in a minute. We also have elastic file system, which is a shared file system across multiple devices or multiple resources. Storage gateway is a solution to allow you to connect your on-premise storage to AWS and allow you to either back up your data completely on AWS, or have it back up to AWS, but also have data accessible to your on-premise devices. And again, we'll talk a little bit more about that. There's Amazon S3, which, as you know, now it's object storage and is infinitely scalable. It has a bunch of different features to allow you to manage your objects, use those objects as a source of data to analyze them. You can host databases. You can do all kinds of stuff with S3. It's also, you have the ability to encrypt your objects at rest and also move them across different regions. Amazon Glacier is more long-term archival storage, and it also has different options, right? So typically what you do is you save your data into S3 and then slowly move the data into Glacier when you no longer need it. And then there's larger storage options such as Snowball Edge and Snowmobile. Snowball Edge is a device that is secure, that is encrypted, that is sent to you for you to download all your data into it and then ship it back to AWS. It's an easy way to move large amounts of data into the cloud. And then Snowmobile is an even larger, is an actual semi-truck that you can use to dump all your data into it and then have it moved into AWS. And it can transfer up to 100 petabytes, I believe, of data in a matter of weeks, as opposed to having to wait years if you were to do that over the internet. Let's talk a little bit about block storage. Block storage as a service is what Amazon provides. It's a way to attach network storage to your EC2 instances, right? It's a way to create and have additional storage. You can attach multiple EBS volumes to an EC2 instance, and we'll see an example of that in a minute. But it's also access over the network. And you may think that that's a disadvantage, right, in comparison to having the storage readily available as part of that VM. But it's insignificant because AWS has a pretty high connection between where that storage lives and where your EC2 instance is. So it acts and it seems as if it were local storage, right? But the reality is that it's not. It is not hard drives, right? It is shared storage that is associated with your account, with your EC2 instances. EBS volumes or EBS storage is durable, is assigned for 5 nines of durability and reliability. is redundant across multiple devices within the same availability zone. It's secure. You can enable encryption at rest for it, and you don't have to worry about how it's encrypted or decrypted. AWS manages all that. You can also attach IAM, identity and access policies to it to determine who can access it. It is also scalable to what you need. Right? You can easily change the size of your storage device or your EBS volume. You can do it from CLI, or you can do it from the console, the AWS console. It's low latency, it's high consistency, and you can also have multiple volumes striped to get higher performance out of it. You can also take snapshots, and snapshots are a point in time, a backup of the changes that have happened on your EBS volume. Right? You can copy those snapshots across multiple regions. You can recreate those snapshots into additional EBS volumes and attach them to additional storage, etc. Okay, so as I mentioned, it is network attached block devices that have an independent life cycle. You can have multiple volumes attached to an EC2 instance, but you can only have one instance attached to one volume at a time. In other words, you can have multiple EBS volumes as drives. You would see them as drives on your EC2 instance, right? But one EBS volume cannot be attached to multiple EC2 instances. You can attach it to different ones. You can take snapshots, you can share those snapshots. It's basically raw block devices. It's unformatted initially. And it's ideal for databases and file systems, your typical, typical file systems that you'd run on your server. There's different devices, different types based on the type of performance that you're looking for, and we'll talk about those in a minute. So there's different types. There's SSD and HDD. You can use general purpose SSDs for typical low-cost workloads, right? You can use IO1, which is provision IOPS, and that would give you higher performance for each one of those EBS volumes, and you can provision specific number of IOPS. And there is a slightly higher charge for provision and IOPS, but you do get a lot more performance out of a regular. So you can also have throughput optimized hard drives, which is the ST1 type, and that's low-cost workloads that require consistent throughput, right? Such as big data, data warehouses, log processing, and you can get up to, I believe, 16 terabytes storage on that. And you can have cold hard drives for large volumes of data that are frequently accessed, and that'll save you additional costs. Different use cases. So I mentioned your basic SSD drives you can use for relational databases, such as MySQL, SQL Server, Oracle, or NoSQL databases, such as Cassandra, MongoDB, CouchDB. One thing to keep in mind is that if you use a regular EBS volume for hosting your databases, you need to make sure that you have backup set up for it, right? That if the EC2 instance that is attached to it dies or gets replaced, then the EBS volume needs to be reattached to a new EC2 instance and that kind of stuff. And that's why there's other options of hosting your databases. And again, we'll talk about that, I think, in a separate section when we talk about databases. But you can. And for HDD drives, you can use them for big data analytics and file and media storage. We talked about EBS snapshots and how one EBS snapshot can only be attached to one EC2 instance, right? But you can have one EC2 instance attached. You can have one EC2 instance that has multiple EBS volumes attached to it. Right? Also talked about how EBS volumes, or you can create a snapshot, and that snapshot is pushed into Amazon S3. It is not pushed into an S3 bucket that you can see, but it is in S3. And when you restore a snapshot from S3, it'll create an EBS volume that's available to you. It's available for you to attach to an EC2 instance. Right, so you can have multiple snapshots of the same EBS volume. There's also instance store, and instance store is what you would typically have when you have a server that has local storage, right? And the difference between local storage and EBS or network storage is that local storage is ephemeral. It is not persistent. It is a little quicker to access things from your local storage than it is from an EBS volume. However, if an EC2 instance dies or it's replaced by an auto-scaling action or something happens to it, then you would lose the data that is in that local storage, right? So it has its applications, right? You just have to make sure you understand that it is ephemeral, that you can't take snapshots out of it, that the data is not replicated and it's not persistent. So with that, I'm going to pass it to Chris so he can talk a little bit about share file systems on AWS. We can't hear you, Chris.
Hi, good afternoon. Sorry about that. When I go from sharing, it changes the mute to the top. Hi, everybody. We're here to talk about shared file systems. So these are services that allow you to share content across multiple instances. The first one to talk about is Elastic File System, or EFS, and it's a managed NFS service that is simple, it's elastic, it's scalable, and it's highly available. You can share it across multiple instances, you can grow it, and you pay for what you use versus having to pre-allocate storage. So it's simple. You don't have to spin up your own, EC2 instances and attach a bunch of EBS volumes and run NFS server and manage that day in and day out like you might do in a traditional data center. All you need to do here is turn up the service and then, do your Unix mount command or edit your etc fs tab file and put the mount point and point it to the EFS service. Again, it's NFS version 4.1, so it's available across multiple operating systems, all your different flavors of Linux. And the pricing is simple. You know what you're using, and you pay for that component of it. The service is elastic. It can grow with you, so you don't have to pre-allocate storage as you grow into it. You don't need to provision extra performance capacity within the service. You can do that through the service itself. And then again, you only pay for what you use. It's scalable, so you can grow to multiple petabytes in size. You can automatically, the IOPS can automatically grow as the file system grows, and you can get consistent low latency, great file performance, regardless of the size of those files, and you can have concurrent connections to the service as well. And as Oscar was talking about before, this is a highly available and highly durable offering. It sustained, the loss of a availability zone. So there's replication. So in a way, it's traditional to you're running a NAS in your own data center, because you don't necessarily have the ability to replicate that across multiple data centers yourself with that. So I see customers using EFS for web serving. There's some solutions that you can set Drupal or WordPress to do content management systems with your web services, big data, media processing. So if you're doing a media workflow where you're passing content, like editing an image, and then you're passing it on to an editor and the like, you can have those systems share those files through EFS to make the management of that easier. Or just having home directories attached to your instances where you have maybe user information and or a set of scripts that you're accustomed to use, and you want to have that readily available on instances instead of having to reinstall or rebuild the image. You can just have it available at that mount point. And then for your Windows workloads, there's FSX, which is your fully managed Windows file system. So it's not NFS, it's the Windows shared file system, and it's built on Windows, and it's for Windows, but it's managed by AWS. And again, this gives you the ability to integrate with your Windows instances. It's native SMB, it integrates with Active Directory, it uses your DFS namespaces and replication protocols. So again, a great way to share files across multiple Windows instances. And then another type of storage we'll talk about today is object store. And this is probably one of the most core and popular or well-known services that AWS offers. It's Amazon S3, which is simple storage service. If you ever wondered what the 3 in S3 stands for, just repeating the S's there. And this is a web accessible object store. So you'll be interacting with these objects through an API or the HTTPS protocol. As Oscar was talking about durability, 11 nines of durability. So very low likelihood of losing a file over hundreds of thousands of years. The system grows. It's huge. It's massive, and it can support your big data needs or your website images. And there's tiers tied to the service that we'll talk a little bit more that can match what you're needing the service to provide for you. And as Oscar was talking about earlier, it has life cycle rules, so you can move your data over time to a tier that it needs during its life cycle, or it's how you're using it throughout its lifespan. So maybe at the beginning it's very popular, and then over time you can archive it. You maybe use files for 90 days, and then your business is like, okay, now we're on the next grouping of projects or the like. And then, as I mentioned earlier, a lot of customers use it for static website hosting, and that might be referencing S3 to serve your images off your website or static content. Or if you have a pure static website in HTML, you can use DNS and point your site to that with a configuration of your S3 bucket, utilizing that host name in the configuration, and configure it for public access. So it provides public access as well as private access depending on the configuration. So it allows you to interact with your data through these APIs or HTTP gets and puts. There's encryption associated with it. It's durable. It's massively parallel in terms of the ability to handle multiple requests across different clients needing to use it. And to get that durability and performance is utilizing the multiple availability zones of a region, so that it provides that redundancy and throughput needs. You can also do some analytical work with it. You can support SQL expressions to do select. So if you have an object and you only need a portion of the file and the like, you can utilize that methodologies to do selects within your file base. So I mentioned that there's different types of S3, or what we call classes with the utilization of S3. So the first and most prominently used is standard, and that's going to give you millisecond access. It's going to use multiple availability zones, and then it has kind of, I think, a really aggressive price point associated with it. But as you move to colder storage, or less frequently, or less durability, or for one case less durability, but all of them have more durability. As you can see, the less that you need to access it, the data, then the more, or the cheaper the cost point comes. So you go from 2 2.33 cents to 1/10 of a cent for Glacier pricing. A lot of different ranges, options available for that. And there's an intelligent tier that allows you to let AWS decide where your storage should go based off of some machine learning algorithms that they have developed to do some optimization for you. Mentioned before, Glacier, this is your long-term archival storage. It has compliance with a lot of different regulations. It allows you to vault lock, which means just lock it and kind of throw away your key for a period of time, which means that no one can access that data. Again, encryption, just like S3. It's replicated just like S3. And it can, it's great for that deep archival, kind of as a tape replacement thought pattern there. Here are some of the different use cases associated with the different storage classes. Again, standard, it's going to be for your web content, things that you're interacting with every day, or like every second or millisecond throughout a day for like web content and the like. And then the infrequent access, it might be for media transcoding temporary files, maybe something that you're just not deep archiving, but an active archive that you might need to retrieve, maybe. You just want it readily accessible. And then Glacier, again, is your offline archives, your tape replacement, your worm compliant data can go into there. So as you understand the different tiers, you can understand the price points getting cheaper the colder you get. And then there's also some retrieval costs associated with the colder tier. So while it comes with a cheaper price point, there is an additional type of charging that would be based off of how often and how much data you do retrieve it, and the minimum block size associated with that tier. And then how long it needs to stay on that tier. So, S3, you're just charged daily, or you're charged, I think, hourly per month for the storage. So if you only have a file up there for 1 hour for 1 month, you'd only be charged a fraction associated with that. Well, with infrequent and Glacier, there's a minimum time associated with how long, a minimum file duration that needs to be achieved there. So now that you know about all these wonderful AWS storage types, how do I get my data to utilize this, or how could I integrate my on-premise systems to work with them? And a very popular solution is Storage Gateway, which allows you to utilize the cloud in conjunction with your on-premise storage. So it provides, this is a virtual device that you can put into your environment to allow you to extend your files or your volumes or your tapes with the respective AWS service. It's designed to fit into your environment and give you those access to those things, very readily and very quickly, and allow you to scale up by utilizing the cloud for these different work use cases. And the Storage Gateway has 3 main flavors. The File Gateway, which gives you a file storage option, giving that ability to store things, utilizing S3 to extend your file storage, a volume gateway, which is ability to give you an iSCSI interface that utilizes S3 and then allows you to access that data in AWS through EBS snapshots, or tape gateway, which is an iSCSI virtual tape library interface, kind of giving you that VTL management interface, but instead of pointing to a real tape, you're providing it to a virtual tape, but your backup system doesn't realize the difference, or is configured to utilize VTL to do that, saving you some tape costs and potentially some offsite storage archival management nightmares. And so the tape gateway is set up as such that it's utilizing S3 and then Glacier. It does compression, and it's an unlimited tape library. So instead of having to rebuy tapes and dealing with that headache, it's just a nice, simple way to utilize these services through that. And they're integrated with a lot of popular tape library backup solutions. And I mentioned earlier, file gateway, that's going to be your NFS service, and it interacts with the files in S3 for you and kind of gives you a solution to access those boxes, those objects on-prem. And you can manage the access through that through IAM, which we'll talk more about tomorrow, but it's a means to protect your access to AWS resources. And also here, it integrates with S3 lifestyle policies, allowing you to archive storage or move data to a storage class that's right for that type of data that you're utilizing or not utilizing. Volume gateway gives you the ability to give a block level, so you would extend a storage device with this iSCSI block storage, and then again giving you the ability to increase the available total storage for your applications. There is a limit of 1 petabyte of volume per storage gateway, so if you need more than that, you would need to utilize a solution that spins up, or you utilize multiple volume gateways with it. But then this utilizes S3, and then if you need the data in AWS, you would create an EBS snapshot and then interact with that snapshot with the EC2 instance. And then let's say you just have, terabytes of data that you are interested in getting into the cloud. Using the traditional internet might not work for you. And then here is where Snowball and Snowball Edge comes in. And so the original Snowball Edge had a 50 and 80 terabyte capacity. And it's a hardened device that has a Kindle-like shipping label to it. So through the configuration or the ordering process, it creates that label. It's in there. It's tamper-proof. It knows that it's going to your location, and then when you're ready to ship back, it automatically flips and goes to the AWS shipping location that would then correspond to the region that you need that data to go to. The new Snowball Edge, the next generation of Snowball, has 100 terabytes of data and allows NFS capabilities through, it actually has a Linux compute power inside of the device that gives you the ability to set up NFS and or run compute for transformation of your data as it goes into the device. Very powerful. And all this again is means to ship it into S3 faster than a traditional internet configuration would be. So here's what the device looks like. You can see the e-reader It's tamper-proof, it's rain-proof, it's dust-resistant. There's some really fun videos on YouTube that show the devices being dropped or near explosions. So very safe, very rugged, a very fun device. If you have the ability to order one and just hit one, there's people who like to take selfies with them when they get them. So just a fun service here that got a lot of people excited. You know, talking about your internet connectivity as you're potentially needing to do a migration event, understanding the utilization of your internet pipes and what you need to do some cost calculations. And then these are things that us at Stratus 10 can help you with to do these calculation and migration plans, but just kind of understand that sometimes sneakernet is faster than the internet when moving these large scale ports of data. And to that extent, Snowball, which is the 100 petabyte solution. It's an actual truck that can come to your data center, thus the Snowmobile, and connect to your network and give you the ability to handle a much larger scale of data than multiple Snowball devices could. So if you have hundreds of petabytes that potentially need to be in the cloud, this is an option for you. Here's a YouTube link that I won't show right now with Zoom, but you can search it on Google if you're interested. It's the unveiling of the Snowball device where Andy Jassy, the CEO of AWS, is on stage at reInvent, and this big truck drives up. It was a fun kind of marketing launch for this really cool service. And that is the end of the storage presentation.